But that window should come, no? Where is that window? This should automatically come, no? This also. Okay, it is coming here, but here. Here. Yes. Then so it's already started, no? I have to. Okay. I don't know. What is unit vector? Unit vector. One. Vector with the magnitude 1. This is x-axis, y-axis, z-axis. If we are considering a unit vector, the length will be only 1. Magnitude will be 1. So this is 3D, 3-dimensional. Along x direction, x direction. Anyway, look. Along x direction, you can take a unit vector. Name, what is the name? Unit vector. I. Yeah, yes, I. Unit vector, matlab, instead of bar, we will put a special status. We will give him a cap. So, this is the unit vector along x direction. Name is I cap. Along y, another unit vector. Magnitude is, that is 1. J cap. Another vector along z direction. Name is k cap. I cap, j cap, k cap. That is a unit vector along x, y, z directions. So when you are representing in a coordinate system, when you are representing a point, you have to say, for example, this is y, x, z. This point can be, this is our point of consideration. This point can be taken down. Yes. So this is actually x distance from, this is the, okay, here, okay. Look like a 3D diagram. Then you can, so this point is in a 3D space. Yes. This point distance normally represented as x comma y comma z. X comma y comma z. What is the meaning? this point is at a unit of x along x-axis, y along y-axis, and at a height of z along z-axis. X, Y, Z is known as this X, Y, Z. All this dimension is with respect to origin. With respect to origin. So when you are saying a coordinate with respect to origin, we can call it as position vector. We can call it as position vector. So if this is P, the point P, the vector can be represented like this. Vector, what is the name of that vector? OP. So AOP can be represented as, what is the x component? X. So xi, yj plus zk. This is known as position vector of a point. Then what is the magnitude means? What is the distance of that point from the origin? That is known as magnitude. So magnitude, if you are given 2 points, x1, y1, z1, x2, y2, z2, what is distance formula? Distance formula is x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. Everything is under root. Similarly, what is this? O? O is 0, 0, 0. So if we are considering this point, this formula, OP can be written as root of x minus 0. x2 minus x1. x2 minus x1, 0. So it can be written as x minus 0 the whole square plus y minus 0 the whole square plus z minus 0 the whole square, because x1, y1, z1 all are 0. So this can be represented as x square plus y square plus z square. It is known as magnitude of a vector. Magnitude of a vector. Now you can see 2 points. For example, A, it is 2, 3, 4. Another point, B, 4, 5, 7. So this vector AB can be represented like this. This is initial point. This one is terminal point. Final or terminal point. So this 2, 3, 4 is the position vector of A. That means OA. What is OA? OA is 2I 3J plus 4K. OB means position vector of B. That is 4I 5J plus 7K. So what is AB? AB means, the vector AB means final position B, initial position A. Final minus initial. Final means OB. Initial means OA. You have to subtract position vector of final minus initial. So OB, what is OB? 4. Then you can add or subtract I together, J together, K together. But you cannot add I and J. Understood? Yes. So 4 minus 2. What is 4 minus 2? 4 minus 2. 2. 2I. 5 minus 3,
2J.
2J. 7 minus 4, 3K. So this is the vector AB. What you have to do? Position vector of final point minus position vector of initial point. Now, what is the magnitude of AB? Magnitude of AB is represented like this. Square of 2 square, 2 square plus 3 square. So you will be getting 4 plus 4 plus 9. 4 plus 4, 8. 8 plus 9, 17. So this is the magnitude. If you want to add two vectors, देखो, a person is playing football. Now football is here. He started to kick. Ball is going like this. After some time he came here. Again he kicked the ball. It is going to this position. So first he applied a force of A. Now he applied a force of B. So this is the initial point. Starting. This is final point. So resultant you can represent like this. So what is this vector? Resultant vector. This is A plus B. A plus B. So R can be written as A plus B. Order should be pakka. This is in this order. After that, we have to put in this order. Yes. So here force is applied not simultaneously. It is applied one after the other. If force is applied one after the other, you have to use triangle law of addition because it look like a triangle. Triangle law of addition you have to use. Another thing, here one football is there. One person is coming here and another person is standing here. Both are kicking the ball simultaneously. He is kicked in this direction, he kicked in this direction. That means here force is applied simultaneously. Here force is applied one after the other. If the force is applied simultaneously, what is the force applied by him? Look like this. What is the force applied by him? It look like this. If he applies more force, the length of that will be bigger. If he supplies lesser force, length will be small. So then by connecting these two, you can make a parallelogram. So in parallelogram, you will get a diagonal in between these two forces. This is actually the result. If this is A and this is B, this can be represented as A plus B. A plus B. Okay. I will give you three cases. One force is applied like this, small one. One another force is applied like this, bigger one. So the resultant will be more towards the bigger one. That is correct. So here the parallelogram will be like this. So and resultant will be more close towards the bigger force because magnitude of A is greater than magnitude of B. That is one case. Another case, a force applied in this direction is bigger and this direction is small. So when you are applying more force on one direction, more resultant will be more close towards that bigger force. So Here you can draw like parallelogram like this. This length indicates the magnitude of the vector or the force.
Yes.
Now the resultant will be like this. First case like this
Yes.
towards A because A is stronger. Here towards B because
B.
B is stronger, strong force. So you cannot say that normally when we are drawing the parallelogram, we normally use it to represent like this. And somebody may think that this angle is equal to this angle. It is not like that. It can be like this and it can be like this. Now, third case. Now A is greater than B and B is greater than A. Both cases we have discussed. Third one, magnitude of A equal to magnitude of B. Both are applying force simultaneously. Now, the length of A and B should be same. This is B, this is A, and this is parallelogram. Since the length of A and B both are equal, the resultant will be bisecting the angle between A and B. For example, A and B, between A and B, there is some angle that is equal to 76 degree. 76 degree. So resultant will be bisecting the angle between the two. What is the bisecting mean? Equally dividing into two.
Yes.
What is this?
35, 36.
So this will be 38 degree and this will be 38 degree. If both the forces are equal in magnitude, the resultant will be exactly middle of the both.
Okay.
Understood?
Yes, sir.
So if these three cases are possible. So when normally when in textbook, normally they will give this diagram. So should not misinterpret that always the resultant force will be at the middle of the parallel as a diagonal. At the middle of the, it can be like this, it can be like this also, or in some cases, if the both forces are equal, then the resultant is equal distance from both.
Yes.
Equal distance from the both cases. So this is look like parallelogram. So here force is applied simultaneously.
Yes.
Therefore, here you have to use parallelogram law of addition of vectors. Understood?
Yes, sir.
When your force is applied one after the other, what do you have to do? When a force is applied one after the other, triangle law of addition. If the force is applied simultaneously, parallelogram law of addition you have to use. Then this is A. And another vector is B. So what is the angle between A and B?
Joining the two tails.
This is the angle. We are dealing with the free vectors. So A and B can be considered like this.
Yes.
This is A, this is B. This angle is the angle between two vectors. You have to see the direction. You have to see the direction. This is in this direction and this one is this is direction. So this angle is known as theta. Angle between two vectors. Now I am considering this vector. Look, this is a triangle 90 degree. This is theta. If this is B and for example, this is ABC. Cos theta, what is cos theta? Based upon hypotenuse. Base is actually AB by hypotenuse B. So cos theta is equal to AB by B. So what is AB? AB is equal to B cos theta. Is it correct? Cos theta equal to base upon hypotenuse. So base is AB. Hypotenuse is AC.
Yes.
So AB, instead of AB, so AC, what is AB? We don't know. AC, what is AC? B. So you have to cross multiply. So you will get AB equal to B cos theta.
Okay.
Similarly, what is sin theta? Perpendicular upon hypotenuse. Perpendicular, who is perpendicular? BC. Hypotenuse is AC. So what? Here you can get AC is, so sin theta equal to BC by AC. What is AC?
B.
So here you will get BC is equal to B sin theta. Understood?
Yes.
So we can draw into like this. This is our vector A, and this is our vector B, and I am extending and I am making a right triangle. This is the angle between these two vectors. This can be represented as B sin theta. BC is B sin theta. What is AB? B cos theta. So this AB can be represented as B cos theta, and this is B sin theta. So now you are able to make another triangle, big one.
Yes.
So for example, ABC, this is D. You are getting a big triangle DBC. DBC. Yeah. That is also right triangle. In triangle of addition, you know that this vector and this vector equal to this vector. This vector A and this vector B, it should be in order. Yes. Here to here, here to here. The net movement is from here to here. Yes. Understood? From here to here, first movement, followed by here to here. So net movement from this position to this position. Yes. It is known as resultant. That resultant is represented as A plus B. So here R is equal to, this is A and this is B. So this can be represented as A plus B. A plus B. So what is the magnitude of R? What is the magnitude of R? Matlab, magnitude of A plus B vector. Now we have to apply the Pythagoras theorem. You can see here, this distance is A, magnitude wise. This distance is B cos theta. So what is dB? In triangle DBC, you can write dB square plus BC square equal to DC square based on Pythagoras theorem. dB, what is dB? This plus dA plus AB. dA plus AB. So instead of dB, I will put A plus B cos theta, the whole square. Instead of BC, I will put B sin theta, the whole square. This is equal to DC square. Matlab R square. R is क्या है? What is R? A plus B. So first of all, you have to solve. This is A plus B the whole square. So A square plus B square cos square theta. A square plus B square plus 2AB. Understood? Yes. 2A क्या है? A. B matlab B cos theta. Because you have to consider this is A, this is B. So you are getting A plus B the whole square. So A square plus B square plus 2AB plus B square sin square theta equal to R square. You can see in both cases B square cos square theta, B square sin square theta, which is common B square.
B square, yes.
So you can write A square plus B square into common क्या है B square. So cos square theta plus sin square theta plus 2AB cos theta equal to R square. Sin square theta plus cos square theta, trigonometric identity. Sin square theta plus cos square theta, 1. So instead of this, you can put A square plus B square into 1. That is fundamental identity of trigonometry. Sin square theta plus cos square theta equal to 1. You should remember for your life. Sin square theta plus cos square theta, 1. Plus 2AB cos theta equal to R square. So you are getting R square is equal to A square plus B square plus 2AB cos theta. Now I am going to put root on both sides. Root on both sides. If you are applying root here, here also you have to apply. Otherwise, the balance will go. So what is root of R square? R. Yes. Which is equal to A square plus B square plus 2AB cos theta. Okay. Understood? Yes, sir. So this is the vector law of addition. Vector law of addition. If the angle between two vectors are given and the magnitude of the two vectors are given, then you are able to calculate the resultant vector. For example, A is equal to I plus 2j plus root 5k. This is my vector. I plus 2j plus root 5k. Root 2 square, 4. 4 plus 1, 5. 5 plus 5, 10. 5 plus 5 plus 10. I will put 11 for my easy calculation. Another vector B is given as 4i plus 3j 16 plus 9 कितना 25 plus 25 root 24k. So what is magnitude of A? What is magnitude of A? Yes. Root of I component. I component square. I component, what is I component? 1. 1 square plus 2 square plus root 11 plus root 11 square. What is this? 1 square, 1 plus 2 square, 4. Root 11 square matlab 11. 11 plus 4? 15. 15 plus 1? 16. 16. Root of 16. What is root of 16? 14. 4. 4. Yes. What is B? 4 square. 4 square plus 3 square. 3 square plus 24 square. 4 square 16. 3 square 9. Root 24 square 24. 16 plus 9? 10 plus 9, 21. 25. 25 plus 24? 49. What is root of 49? 7. 7. So in order to get a value like this, I am put root 11 and root 24. Okay. It can be anything. Now they said me, this is A and this is B. And they are given an angle of 45 degree between two.
Okay.
What is that? Is
Theta.
theta. So which one is bigger one? B.
B. Yes.
So resultant will be more towards B, because which force have more magnitude, more power, the resultant will be more towards that side.
Yes.
Since they are not equal, the resultant will not be at the middle.
Middle. Yes.
Who is bigger? In that side, he will have some tendency to move because he is more powerful. Understood?
Yes, sir.
Now, what is the resultant?
Equal to.
So this A, B, matlab, you can write like this also. This is A and this is B, because free vector. You can take that vector into anywhere in this space without changing the direction and magnitude. So this can be drawn like this also. So this is your 45 degree. So this is your resultant vector. Actually, resultant is like this, but it is a free vector.
Yes.
You can take that vector to anywhere in this space without changing magnitude and direction. Now, R, what is the resultant R? Magnitude I will calculate. Resultant R equal to root of A square plus B square plus 2AB cos theta. So, A square, what is A square?
A square is
4. 4 square, 16. Understood?
16.
B, 7. So, B square, 7 square, 49.
Yes.
2 into 4 into 7 into cos 45 degree. Understood?
Yes, sir.
Now, 16 plus 49. 65, na? 65 plus 2 into 4, 8. 8 into 7, 56. Into cos 45, 1 by root 2. So just for better calculation, suppose I am giving 30 degree here. For example, this is 30 degree.
Yes.
Just for easy calculation.
Okay.
Cos 30, that is root 3 by 2. So I will put 60 degree. 60 degree. If it is 60 degree, other also you can do just for easy calculation. Cos 60 actually 1 by 2.
1 by 2. Okay.
Root 3 by 2, 1 by root 2, 1 by 2. So 1 by 2, you will get a 1, 2,
Yes.
28, 2. 28 plus 65, 85 plus 13, 6 plus 2, 8 plus 1, 9. So you are getting root of 93. The magnitude of the resultant vector will be 93. What is R? R can be written as, normally it can be written as A plus B. That is simply add the two vectors.
Okay.
For this, you have to add 4 plus 1?
Yes.
5i.
5i.
5i. You can 5i plus another 3 plus 2?
5j.
5j plus root 11 plus root 24. You have to write like this. Root 11 plus root 24 into k. Because root 11 we don't have direct answer. So then what is okay. So if you are checking the magnitude of this one, you will get that value. For example, we can check magnitude of R is equal to, what is the magnitude of this vector? 5 square plus 5 square plus root 11 plus 24. root 11 plus root 24 the whole square. So you have to 5 square plus 5 square 25 plus 25 plus this is a plus b the whole square 11 plus 24 plus 2 root 11 root 24 a plus b the whole square a square plus b square plus 2ab. So 25 plus 25 50 plus 11 plus 20 11 plus 24
No, 11 plus 94, 35.
35. Yes. Then 2 root 11 root 24. So there is a little bit calculation is required. So that is the resultant vector. Understood? Now, another thing. This is A. This is B. This is the angle between two vectors. So resultant is like this. So resultant angle, suppose I am considering it as alpha. So this can be written as this. What is this value? B sin theta. This is B cos theta. So tan alpha is equal to perpendicular upon base. Perpendicular actually B sin theta. Base is actually this plus this. A plus B cos theta. Understood?
Okay.
So that are the formulas. So this theta represents the angle between two vectors and alpha represents the resultant vector direction at which angle. For example, there is this A, this is B. A, B.
Yes.
This is theta. Now you are getting a resultant like this. So this is alpha. At what direction the resultant is there? Understood? This is a vector. This is another vector. This is A. This is B. And resultant is like this. This total angle is theta, but you have to calculate alpha. That is the resultant vector angular direction. बाद में लेंगे ये आपका बुक है ना Yes, sir. Pardon? Yes. Someday I need to go for charge. Yesterday we came home.
chemical bonding, right? Don't have chemical bonding.